This video is about 6 trig functions. In geometry class, we already learned 3 trig functions: sine, cosine, and a tangent. For a right triangle, for the angle theta, we can find the opposite side and then hypotenuse side. Then the other leg will be adjacent side. We have SOHCAHTOA to remember the definition of a sine, cosine, tangent. For sine theta, that's the opposite over hypotenuse. For cosine theta, that's the adjacent over hypotenuse. For tangent, that's opposite over adjacent. Normally, we call these 3 trig functions sine, cosine, tangent is a major trig function. The other 3, cosecant, secant, and a cotangent, we call it's a minor trig function. And a cosecant theta will be related to sine theta because it's a reciprocal of sine theta. Secant theta will be reciprocal of cosine theta. Then cotangent theta will be reciprocal of tangent theta. For these 2, I don't worry about that. So far, no students will be confused with these 2. But normally, students are confused with cosecant theta and then cosine theta. They think cosecant theta should be related to cosine theta because both has cosecant, cosine. And sine theta will be related to secant theta. But the fact it's not. That's how you remember. Cosecant theta will be reciprocal of sine theta. Remember the first letter is different. Secant theta is a reciprocal of cosine theta. You see the first letter is different. Let's talk about the name of each trig function. We have sine and a cosine. We have tangent. Then here's cotangent. Then we have secant, then cosecant. So we see sine and a cosine are co-function. And a tangent and a cotangent, they are co-function. Then this secant and a cosecant, we see co-function. for co-function, there is a very important formula. Let's talk about sine and cosine, because we already know that cosine 30 degree equals sine, what degree here? Will be 60 degree. And sine 45 degree equals cosine will be 45 degree. And cosine 0 degree equals sine, what degree here? It will be 90 degree. So did you see the pattern? Can you figure out cosine 14 degree equals sine what degree? It will be 76 degree. Because from these three, we know that adding will be 90 degree, 45, 45, 0, 90. So you can change any trig function into its co-function by doing 90 degree minus theta. If we see this part is a theta degree, then you can change any trig function into its co-function. For example, if we have secant 70 degree, it equals cosecant. What degree will be 90 minus 70 will be 20 degree. And for tangent 85 degree will be cotangent. Using 90 minus 85 will be 5 degree. Therefore, here is a co-function formula. It will be tested on SAT. For any sine theta, you can write down cosine. If it's a degree, we do 90 degree minus theta degree. But if this theta is a radian, I can write down cosine pi over 2 minus theta. For cosine theta, it will be cosine, we count as degree this time, it's 90 degree minus theta degree. For tangent theta, will be cotangent 90 degree minus theta degree. For cosecant theta equals secant theta 90 degree minus theta degree. So the same to secant theta and then cotangent theta. Now let's go to guided practice for 6 trig functions. Use the given trig function value of acute angle theta, that's the keywords, acute angle theta, to find the exact values of the 5 remaining trig function values of theta. First of all, we know this is an acute angle. Sometimes the question will say angle theta is in a right triangle. In this case, still we know that theta is an acute angle. So how can we draw this acute angle? Let's draw a acute angle in a coordinate plane. For this coordinate plane, we know that this will be the 0 degree, 90 degree, 180 degree, and 270 degree. Then go back to 360 degree. What's acute angle? Acute angle means this angle between 0 and 90 degree. So I will draw this. We see this is a theta because this is acute angle. And I will label the coordinates for these points. Let's do x, y. I want to form right triangle so that I can get the sine, cosine, tangent. We know that for right triangle, using SOHCAHTOA, we can figure out sine, cosine, and a tangent. So I will draw right triangle like this. So for this right triangle, and the distance between origin and this point, let's label as r. And then for the opposite side, the length of opposite side will be y. And adjacent side will be x. We also label that hypotenuse, opposite, and adjacent side. Then we use SOHCAHTOA to figure out sine, cosine, and a tangent. So we know that sine theta equals OH. That means y over r. For cosine theta equals a over h. That means x over r. Then we got tangent theta equals O over a. That means y over x. This is a very, very important formula you need to remember. Then let's go back to this right triangle. And we know for right triangle we have Pythagorean theorem. Therefore, we can figure out that r equals square root x squared plus y squared. And x equals square root r squared minus y squared. Then y equals square root r squared minus x squared. This is the relationship between x, y, and r. We are using these two sets of formula to solve guided practice. This is the sixth formula we just got. We got to use this one to solve for question 1. Cosecant theta equals 5. Remember, we love major trig function, sine, cosine, tangent, because we have so much information of them. But for minor one, we just know it's will be reciprocal of sine, cosine, tangent. So whenever you have a minor trig function, first step, we need to change into major trig function. So we know sine theta is related to cosecant theta. When cosecant theta equals 5, we can figure out for sine theta will be equal to 1 over 5. For sine theta, we can label now, because for sine, that's y over r, which means your y equals 1 and r equals 5. Therefore, you got to know x equals square root. R squared minus y squared means 5 squared minus 1 squared. That's equals square root of 24. For square root of 24, how to simplify? You have to check for this number, do they have a perfect square number as factors? So normally we only need to check that prime number squared. For example, 2 squared is 4, 3 squared is 9, 5 squared is 25, then 7 squared is 49. Next one will be 121. So normally we use these 4 numbers to check whether it's simplified radicals or not. So for 24, you will see, can we divide by 4? Yes. So I will do 4 times 6. Then for square root of 4, we got 2. Then square root of 6. We know square root of 6 is a simplified radicals, because for 6, you cannot divide it by 4, 9, 25, 49. So we simplify as 2 square root of 6. Now we can use x, y, and r to figure out another 2 major trig functions. Therefore, for cosine theta equals x over r, that means 2 square root of 6 over 5. Then for tangent theta equals y over x, means 1 over 2 square root of 6. Then we simplify. When you simplify the radicals as a denominator, here's the formula to use. 1 over square root of a equals square root of a over a. For example, if I have 1 over square root of 7, you will get square root of 7 over 7. If you have 3 over 2 square root of 5, then you got to jump this square root of 5 as a square root of 5 over 5. Then carry on this 3, do the multiplication, and a 2. Therefore, your answer will be 3 square root of 5 over 10. One more. If we have 2 square root of 10 over 3 square root of 7, still you need to jump this one, square root of 7 over 7. Then carry on that 2 square root of 10 here. Then 3 here. So we do multiplication. You will get the 2 square root of 70 and over 21. Square root of 70, we cannot divide it by 4, 9, 25, 49. That's a prime number squared. Therefore, it's simplified. Then this will be the answer. Therefore, for square root of 6, I will get the square root of 6 over 6. Then I carry on this 1 and I carry on this 2. You will get square root of 6 over 12. Now we will get its related minor trig function. For cosine, we will get secant theta we flip, and you will get 5 over 2 square root of 6. Now let's simplify for this. I got the 5 over 2 square root of 6. So we jump at the square root of 6 over 6 for this one. Then carry on this 5 and a 2 multiplication. So we got 5 square root of 6 over 12. We got 5 square root of 6 over 12. That's for secant theta. And for minor trig function related to tangent will be cotangent. So we got cotangent theta equals, we flip. But here's the shortcut. When you flip, it's easier flip the middle one. We got 2 square root of 6. You know, when you do the math, you have to do the math wisely. Always look for the shortcut to get the answer fast. If you flip this one, I will show you how much work you have to do. You will get the 12 over square root of 6. So you got square root of 6 over 6, then carry on this 12. Then you reduce. Did you see you got the 2 square root of 6? Same answer. But you did more work about that. Now let's go to number 2. For number 2, you are given minor trig function, so you need to switch into major one. Tangent theta equals 4. But we need a fraction 4 over 1 so that we can label x, y, or r. For tangent theta, we label as y over x. Therefore, you got the y equals 4 and x equals 1. So r will be square root of 4 squared plus 1 squared. That's a square root of 17. Square root of 17. 17 cannot be divided by 4, 9, 24, 49. So it's simplified. Therefore, we can get another 2 major trig function. That's sine theta equals y over r equals 4 over square root of 17. That means square root of 17 over 17. I carry on that 4. Then I will get the cosine theta equals x over r, means 1 over square root of 17. Simplify, that's square root of 17 over 17. Then we will work on the minor one related to sine theta, that's cosecant theta equals. Remember, we flip middle one so that we can do less work. That will be square root of 17 over 4. The minor trig function related to the cosine theta, that's a secant theta. Still, you need to flip this one. That's a square root of 17. Yeah, that's all for number 2. Now let's go to number 3. Cosine theta equals 6 over 7. Since this is a major trig function, we can just label directly. Cosine theta, that's x over r. Therefore, we got x equals 6 and r equals 7. Therefore, we got y equals square root 7 squared minus 6 squared. That will be square root of 13. Square root of 13 is a simplified radicals. Therefore, I can get another two major trig function, that's sine theta equals y over r. That means square root of 13 over 7. Then for tangent theta equals y over x. That's square root of 13 over 6. Now we will get the minor trig function related to each major trig function. For cosine theta, we know that's secant theta. It equals, we flip, then get 7 over 6. For sine theta, that's a related minor trig function will be cosecant theta. We flip, you get 7 over square root of 13. Then you can do 7 square root of 13 over 13. For tangent theta, its minor trig function will be cotangent theta. It will be 6 over square root of 13. That will be 6 square root of 13 over 13.